Hello and welcome to this session 17 of Bridget Tech's online training. Today we're going to look at the MicroVB and its controller system, the Micro Device Controller, or MDC as it's usually shortened to. The MicroVB is a small, as you can see from the diagram comparing it to a €1 coin, it's a small device and it's also low cost. It can be placed anywhere towards the edge of a network, and it does deep packet analysis and monitors network performance at the edge. It also has alarm thresholds and can report alarms back to the MDC. It can monitor multicasts and OTT traffic. You can connect it in line with a set-top box and use power from the set-top box, USB power from the set-top box, or from any convenient outlet. The MicroVB can perform real-time analysis in the network, performing really quite deep network analysis and packet analysis. And this, combined with other Bridget Tech system probes, will give complete end-to-end visibility. It monitors IPTV as well as OTT traffic with passive or active monitoring. Users can supply a global whitelist that gives a list of all multicasts to be monitored by the probes. Additional to this global list, individual probes can be programmed with their own list of multicasts, and this local list will supersede the global whitelist. I'm not going to read all the bullet points out. Full information is on our website, as it is for all of our other products, and you can see the URL at the bottom of that slide. So the Micro Device Controller is actually a subsystem of the VBC, the Video Bridge Controller. In fact, it actually appears as a MDC Site. It can run on the same physical server as the VBC, but preferably it should run on its own server. The MicroVB itself is a 100 base T interface device. It's very simple to configure, as it's already pre-programmed to contact the MDC as soon as power on is connected and an Ethernet cable. It will find its way through the network back to the MDC. The MDC itself will report monitoring data and alarms upward to the VBC, and this allows the VBC to integrate the data from all of the MicroVB probes into its overall alarm database. And this gives you this very genuine end-to-end picture of network performance. As you can see, there are several ways of connecting the MicroVB. I've just shown 3 here. Most customers will use it right at the edge of the network in a customer's home. This is cheaper than sending out a truck, and it also provides long-term 24/7 analysis of the traffic through the residential gateway into the set-top box. But it can also be used somewhere like a DSLAM or the access switch layer, so we can monitor slightly further up into the network. But in reality, anywhere there's an internet connection, you can connect a MicroVB and provide traffic analysis at that point. So this table shows you the traffic that the MicroVB can monitor. I'm not going to read them out. I'll just leave this slide up for a second or so. So this is a typical screen grab of a video bridge controller, VBC. As you can see, the MDC appears as a site, and this, as I said earlier, brings the monitoring data into the main system. Now here on our demo system in Oslo, our micro device controller, our MDC Site, in fact has 2 MDCs deployed. You can do that. A site can have more than one device. And as far as the VBC is concerned, the MDC is a device. So we could have 2 MDCs. You could have them geographically separated. You might be looking at a completely different customer base with one MDC, and you don't want to mix the data with a completely separate MDC. That's entirely possible to do this. Looking at the individual devices, we can group MicroVBs into groups that we give names to. Typically, these are geographical groups. So a group can contain one or more probes inside that group, and then we can see alarms that are aggregated on a group basis. This enables a little bit better fault finding when you're trying to locate a fault, maybe geographically in a distribution network. Then we can actually look at the device and all of the devices in this particular group. We've got a group called elements, and our MicroVB probes have all got names and they happen to be elements. So we can see the current status of individual probes. You can see from this particular drawing, this particular grab, we've only got one MicroVB actually active at the moment. Then we can look at the streams that MicroVB is currently monitoring or has been monitoring over the past 3 days. And then we can look at the individual streams, and up comes the very familiar media window that most operators will be completely familiar with from our system probes. Exactly the same functionality as the system probe. So immediately operators will be right at home with the way the MicroVB displays data. Okay, so enough slides. Let's actually look at this live in action. Okay, so here we are at the demo system in Oslo. As you can see, the MicroVB and MDC appear as a site, as I described earlier. So it's one site amongst many sites on the VBC. So just clicking on that brings me up to the MDC site itself, and you can see that we actually have 2 MDCs configured. Now, it is entirely possible to have more than one MDC. Most users will only have one, of course, but we've got 2, and it is possible. So we're going to be looking at the MDC demo. Now, the first thing you see is a list of all these devices. I want to tell you right now that many of the devices that we've got configured in our demo system, remember this is not a production system, in our demo system are not connected. They have been connected, and you can tell which ones have been connected by the fact that they've got a set-top box MAC address and a gateway MAC address. Where you see, like for example in this one Venus, where there's no entries into that column, this MicroVB has never contacted the MDC. So again, that's a useful way of seeing which devices are currently in contact and which devices have never contacted. So there are several things I want to show you on this screen, but before that I'm going to go back to groups. Groups again are a logical way of grouping multiple MicroVB probes. Again, they are user definable, so it's up to you what you call them. Typically they would be geographical, but they can be anything you like. You could have a lab-based system and a production system out actually talking to individual customers with them MicroVBs in customers' houses or in DSLAMs, whilst you still have a group for testing in the lab. Anyway, all of these you'll see that we have metric periods 10 minutes going up to 30 days. And you can see the active group that we're going to be using is one that I added a few days ago called training. And you can see that training group has 2 devices actually in that group. And we have had some errors. We've had 0.1% errors. And we'll have a look at those in a little bit more detail later. But we can see over 5 days, for example, you can see how these training probes have actually only been around for about 3.5 days. And something in the group Micropolis also popped up. And if we look at 30 days, we might see even a bit more action. Yes, we can do that. Anyway, as with always when you see a bulb on the left-hand side, the bulb indicates the current state. So we'll go back to 60 minutes. Let's go back to devices because I want to show you some of the displays on that particular tab. Now it's got a grey column header as in multiple places in our probes. So for example, if I wanted to bring the currently active MicroVBs to the top of the screen, I could use this button here. I could use this column header here and bring them to the top of the screen. And you can see that we currently have 4 active MicroVBs. So the 2 I'm going to be looking at are Martin and another one called Server Room 3. You can see they've got MAC addresses on both of those, and there's a timeline. And this is really important because this gives me an overview of 60 minutes in this particular case of how these particular MicroVBs have been behaving. And we've got some error statistics. Let me take you along the top here. Well, the number of errors as a percentage of the time monitored, and bandwidth errors, inter-arrival time errors, media loss rate errors, and RTP errors. Now, ZAP just means that this particular probe, this particular MicroVB, is set to zap between multiple channels. In other words, this has been actively programmed, and I'll show you how we do that in a minute. It's then telling me that we have no set-top box. If we look at the beryllium probe here, the beryllium probe doesn't have this little zap lightning flash, and this means that this probe is actually in a passive mode, and this is looking at all of the traffic that is going through in a standard configuration between the residential gateway and the set-top box, and this would be monitoring all the traffic passively. However, as I said in the first section, we are able to program individual MicroVBs to look at the channels we want to look at, or it can operate in the passive mode. So the 2 that we're going to be looking at are basically in the zap mode. In other words, they're pre-programmed, and I'll show you how we do that in a moment. So if I went back to groups, for example, and I wanted to show the training group, then we'd see the training group and it would automatically go into the multicasts. Now what we're showing here is for that group of those 2 MicroVBs, we're actually seeing all of the multicasts that are being monitored by these 2 MicroVBs. And if you look really carefully on this display here, you can see that this green line indicating a testing period is staggered, and this is effectively as the probe goes around the different multicasts that have been pre-programmed, and it checks them for a certain amount of time, and then it leaves that multicast and joins the next multicast, and you can see that progress down the timeline. So that's how it works, and you can see the errors on the individual multicasts. Okay, I want to go to the setup because I want to show you about the programming of a group of multicasts. So we have this beacon tab. Now the beacon tab has a whitelist, and in fact it's called here multicasts to monitor, but this is a whitelist, and we can add a whitelist and we can give it a name. I'm not going to add one for now, I just want to show you how it works. We enable a particular whitelist and we give it a name, and we give it a starting multicast IP address and a finish address, and then we put a port number in. So that will, you can see that this is actually not enabled, this one. So we don't actually, although we have a whitelist in this table, we don't have a whitelist that's actually been enabled. So effectively what that would mean would be that in a standard configuration, the MicroVBs would all be in the passive mode because this whitelist hasn't been enabled. And as you can see, you can add more than one whitelist. The beacon is where you program the beacon and give it a server address, and this is the server address where the MicroVB, which has been pre-programmed, This is where the beacon comes from, and the beacon is what the MicroVB looks for before it starts to send a multicast back. In fact, it's a single packet that it sends back to the MDC, the micro device controller, when it's been installed somewhere out in the network. And this is part of the discovery of the MicroVB and the MDC being able to contact the MicroVB once it comes online. And once the beacon has been recognized and once the communication has been established, then that path through the network is also established and two-way communication can continue. We can upgrade devices to provide automatic upgrades as well. We enable the beacon. Well, ours is not enabled because all of our MicroVBs are actually in the lab, the test lab. So all of the devices here, we can edit particular device. So let's find Martin. There it is. So we can edit that device. And then we had this thing called the magic string. Now, as I said earlier, the whitelist refers, or the whitelist, when it is enabled, will configure all MicroVBs in this MDC. However, it's possible to override the whitelist on individual MicroVBs using this note, or we call it a magic string, and it has to form in this. And it has to be formatted in this particular format. So it starts with an underscore, then it has the start multicast address with a hyphen and the final multicast address, followed by the port number and then another underscore. And we can decide which group this particular probe goes in. And if we want to give it an latitude and longitude, then it will appear on a map and then actively join. So this is a licensed feature. Active join requires a license, and that the whitelist contains the channels to monitor. So we can do that to multiple probes. We can delete them and we can blink the LEDs. Now this is quite useful in a scenario. It's a bit like the server rack when you're trying to, if you've got a full-size 19-inch rack full of 1RU servers and you need to go around and disconnect the power on one of them from the back. And what you can do with the server rack is to press a button on the front to blink the LED around the back. So when you go around the back, you can identify easily that particular 1RU server. Well, we can do exactly the same thing with the MicroVBs. If you've got a bank of them, and you might well have them in a lab or in some facility in an MCR, constantly checking multicasts. So these would be very useful for checking multicasts continuously. So we can activate a particular MicroVB's LED and we can see it. So we might need to disconnect it, for example. So we can blink the LED. Multicast setup. So as you can see, we can give the multicast a name. And this is really important if we want to trace streams all the way through the system from the head end right through to the end customer. If we give it a name and we report it to the VBC, then this name remains intact all the way through. Thresholds, well, they're basically very similar to the IP probe thresholds. We give them a name. We've got inter-arrival time and media loss rate error. Inter-arrival time media loss rate warnings, minimum maximum bit rate, no signal timeout, RTP drop limit. And then we can add the error seconds. If you haven't watched the video about the difference between probe and VBC alarms, I urge you to go and have a look at that particular video because that will explain how these error second alarm windows work. And we can add groups here. We can just add a group. So going back to the device, let's have a look at my device. So we have the overview here. There's that string there's the magic string here. So this probe, we saw that the whitelist wasn't enabled, but had it been enabled, then we could change the, so we might only want to, this particular probe, we may only want to round robin, if you like, zap through 10 multicasts, and that would be the easy way to do it here. So these are all the streams that this probe has been monitoring over the last 60 minutes or 24 hours. And we can go up and down here and look at them. So you can see this little probe, this MicroVB, has actually going through all of these multicasts and checking them. So if we open one of those, let's just open one of those, and we can go to 30 days. This hasn't been running for 30 days. It's only been running for the past 5 days, 4.5 days. So, but we would see 30 days of data there. Let's look at one of these. Okay, I've had to switch to a different view. I'm not looking at the MDC through the VBC anymore. I'm actually looking directly at the MicroDevice Controller. It's a server application, so we can actually go straight to it. So let me just get that a bit larger. I've had problems with my, not problems, but I have an issue with my VPN. So that's the reason that I've had to go directly into the MicroDevice Controller itself. This wouldn't normally be the case in a production system, of course. So I was looking at the probe that has my name, and we were looking at the streams. Excuse me, one of the few benefits, in fact, of going directly to the MDC is the speed of response is ever so slightly faster, because the MDC is responding to this web browser, not to the VBC, which is then passing on the information via its web GUI. Let's pick one of these streams. So this is the MicroVB called Martin, a single device, and it's looking through a whole list of multicasts one by one. And if we just pick up one of these, we can see the standard media window that you would see in any IP probe. Inter-arrival time, in other words, IP jitter at the top, and media loss rate, dropped packets at the bottom. So let's have a look at one of these. There's not really much to see because this is a very well behaved stream. So if we look at that, we've got an inter-arrival time of 1.3 milliseconds and no dropped packets. And it was monitoring this particular multicast. Let's try and find it again. It was monitoring this multicast for a minute, and then it moved on to the next one. And if we had any jitter in that minute, then it would register. In fact, have we got anything? No, we don't have any misbehaving streams here. We must have something misbehaving. Let's see if we can find one of the multicast streams. They're all green, you see. There aren't any. We'll have to look for another one. We'll come back and look at a stream in error to see what it looks like. But it, in fact, will look exactly like a media window from an IP probe. We can look at the stream itself, so this BBC Brit HD, and this gives us a view of all of the probes, the MicroVBs that are currently looking at it. That probably wasn't the best one to do. Okay, so we're suffering from the problem where I have only got a couple of working MicroVBs. So this particular multicast, the Eurosport multicast, is in fact being monitored by 2 different MicroVBs, and here we can actually see them. So we can either look by the probe itself and look at all of the multicasts that the probe is looking at and monitoring, or we can look at the multicast itself and see which probes are monitoring it and how this multicast is being received by all the different probes. Now this would be really useful if we had multiple MicroVBs out at the edge of the network looking at different geographical locations. And this would be a perfect tool to say, yes, we're getting issues at one particular geographical location where we've got maybe a dozen MicroVBs showing issues, but the other 150 MicroVBs, they're not showing any problems. So this would be a great way of narrowing down errors that you're seeing in the distribution part of the network. Views. This just gives me an overview of all of the multicasts that the probe is looking at and some join latency. So this would give us how long it took to join that particular multicast, and the average bandwidth, time to live, type of service, and the number of errors. So this gives us another view of all of the multicasts being monitored by this particular MicroVB. Traffic, now you can see it's waiting for reply there. So this shows the traffic that the MicroVB is monitoring, and it will give us information. So this could be useful information if you're trying to track down some errors, join errors. You couldn't see the beacon, for example. IGMP, which would be very important for joins and leaves. So you can actually look at some of the traffic here. We can see those as bandwidths and how they relate to the other protocols, and even frames. We can show all protocols, even though we're not actually seeing some traffic on some of those protocols. And if we were looking at OTT traffic and TCP, then this would appear here as well. Now we can do some capturing. We can do some fairly simple capturing on the UDP types here. So we can select traffic to capture. Now it will only capture the headers, it won't capture the payloads. Bear in mind this is a 100 base T device, so you really don't want to be sending a lot of video down this device, and also of course it would affect the network going backwards. So take a snapshot of a particular number of bytes, forward it to this IP address, so a PC somewhere in the MCR for example. You could filter by IP addresses, you could filter by TCP port, and we could trigger on an event. So we could trigger only when we saw an IGMP packet, for example, and that would trigger this snapshot. And then we can generate a report for this particular device and download it. It hasn't been running for long enough really to generate, so we can do that, but on an individual probe basis. So again, this is quite useful if you're looking at one or more probes that have been seeing a lot of errors. It might be very useful to generate a report. Okay, now we go back to the multicasts again, and this lists all of the multicasts that are configured in the system and which probes are looking at them. So let's just pick up TV3 HD, for example. And this will show me the devices that are looking at this individual multicast. Again, not many. Servers, the multicasts are served from different servers. And so this gives us a view of which servers are causing the errors. Again, another mechanism for identifying where faults are in a system or where issues may lay. Maybe they only are in one particular server, in which case this would show up in this view. Okay, so the next tab along is the map tab. Now if you remember, when you set up the individual devices, you can put a latitude and a longitude into the individual MicroVB, and that way will enable you to place it onto a map. Of course, this is a world map, and we do have a couple of MicroVBs spread around the globe. But I want to show you the one that has my name on it, because earlier I put my own latitude and longitude. And if I go to the devices and look for Martin, then you can see that The location of this MicroVB shows up on a map. In fact, this is actually a bit of a cheat because the latitude and longitude is my home address, where my home office is, but in actual fact the MicroVB is in Oslo, so it is possible to fool it. Going back to the map, if there are issues with a particular MicroVB, it's showing an error at this particular point, then that would change the colour of the marker. As you can see, most of these MicroVBs are grey, in other words not in contact with the MDC, but one is. And if we click on that one device, then it will give us that MicroVB's display, and we can look at the individual streams, and we could look at any errors that were showing. And the colour of the flag would change depending on the seriousness of the error. We saw the setup earlier, so I'm not going to go through that again. If we look at the about, it's just basically the version number of the MDC and licenses that have been enabled. As you can see, there are several licenses, including the map license and reports. So these are all options that you only pay for if you want to use them. So that wraps up this quick look at the MicroVB probe and the MDC micro device controller. I hope you found it useful. If you want any more information, contact me directly or contact your regional sales manager. It's a very useful device that many customers have used to extend the reach of their monitoring system. Now, don't forget to take the quiz that accompanies this presentation and test your knowledge.